The discovery of new gravitational waves from the observation of a neutron star collision 130 million light-years away, means for the future of astrophysics. What are gravitational waves? What is the significance of this study? What does Einstein say about gravity? How are these waves detected? What is LIGO? GS Paper 3, Science and Technology. What is the context about? 2 weeks ago, the Nobel Prize in Physics went to three of the leading scientists behind the 1,000-strong international project which first detected gravitational minuscule ripples in the fabric of space-time. The scientists witnessed the electromagnetic lightning and gravitational gusts from the stormy collision of two neutron stars in a distant galaxy. In February last year, scientists announced the first detection of gravitational waves, 100 years after Albert Einstein proposed their existence in his landmark general theory of relativity. What are gravitational waves? Gravitational waves are small ripples in space-time that are believed to travel across the universe at the speed of light. They are like tiny waves on a lake. From far away, the lake's surface looks glassy smooth, only up very close can the details of the surface be seen. They were predicted to exist by Albert Einstein in 1916 as a consequence of his general theory of relativity. What is the significance of this study? Discovery of gravitational waves would represent a scientific landmark, opening the door to an entirely new way to observe the cosmos and unlock secrets about the early universe and mysterious objects like black holes and neutron stars. These findings also provide a new direct measurement of the size of the universe. Nearly 2 seconds after the gravitational waves were detected, the Fermi Space Telescope registered a short burst of gamma rays. This blast of energy solves mystery behind gamma ray bursts. What does Einstein say about gravity? While Sir Isaac Newton visualized gravitational force as a pulling force between objects, Albert Einstein opined it to be a pushing force due to the curvature of four-dimensional space-time fabric. The curvature of space-time stems from the dent heavy objects produce on space-time fabric, which can be compared to the dent one could see on a plastic sheet when a massive ball is placed. How are these waves detected? Scientists have been trying to detect them using two large laser instruments in the United States, known together as the Laser Interferometer Gravitational-Wave Observatory, LIGO, as well as another in Italy. The twin LIGO installations are located roughly 3,000 kilometers apart in Livingston, Louisiana, and Hanford, Washington. Having two detectors is a way to sift out terrestrial rumblings, such as traffic and earthquakes, from the faint ripples of space itself. The LIGO work is funded by the National Science Foundation, an independent agency of the U.S. government. What is LIGO? The Laser Interferometer Gravitational-Wave Observatory is a large-scale physics experiment aiming to directly detect gravitational waves. LIGO operates two gravitational wave observatories in unison, the LIGO Livingston Observatory in Livingston, Louisiana, and the LIGO Hanford Observatory, on the Do-Hanford site, located near Richland, Washington. These sites are separated by 3,002 kilometers. Since gravitational waves are expected to travel at the speed of light, this distance corresponds to a difference in gravitational wave arrival times of up to 10 milliseconds.